the most advanced operators. But when you're not using the ladder, well, the first three can be easily replaced by Kotlin and its features. Okay, let's start from Retrofit. So, while I was doing this talk, I was using the version 2.5.1 snapshot, which was around for a while, and was the only one that supported the suspending method. So I already shipped my slide to the conference, and then Jack Wharton decided to release the new version. Because why not, right? So I had to update my slides. So, what does it change from Coroutines to RxJava? Actually, from the API perspective, not that much. Because, well, on the first line, we see what is like a usual RxJava call, right? So we return a single of something, and it's just a function. Well, with coroutine support, well, we remove the single, and also the generic, which is not good, and we just invoke the suspending method. So, from the interface we build, is not that much work, right? We just need to change a word. So instead of single, we use the suspending keyword, and that's it, right? Fairly easy. When it comes to building the retrofit service, we just need to change the call adapter factory. So from RxJava 2 call adapter factory, we use the coroutine call adapter factory. I'm not 100% sure that this coroutine call adapter factory is needed, like it's mandatory, but I couldn't make retrofit work with version 2.5.1 without that. Maybe in 2.6.0 it's not needed, but as I was traveling here, I couldn't really try it, so I'll tweet about it as soon as I get back home. So this is the real difference between the two. We just need to let Retrofit know what to use to create its calls, and that's it, right? So it's fairly easy. So when it comes to testing, well, we see that it's actually where coroutines really comes handy with Retrofit. So let's check out how it will work with the two frameworks. So here below, we see how RxJava manage that. Of course, we can use, instead of the test operator, a blocking get. Yeah, but if we don't want to use the blocking get for any reason, and we go for the test approach, which is my favorite, well, it's kind of complicated just to understand what I want to be put here in the assert value. It's not easy. There are not many examples on the web, and it looks like nobody really wants to test API request. Why I want to test API request? Well, I don't really test API request per se, but usually you want to know what you're sending to the backend. Because maybe you're sending an header that is changing, or you have to send a particular header based on some other parameters that you have on your device. So you might actually want to test that. Of course, this is not the way to test that specific part, but well, most of the times I find myself writing something like that, also to test what I get back from the server. So with coroutines, what we do is simply wrapping everything into run blocking. Then we can run the call as it was synchronous programming. There is something else that I've been pointed out recently, which is run blocking test, that also affects the delay in your code. Since there we don't have any delay, it was fine to run blocking. Another thing that run blocking test, which is just appending test to run blocking in the end, is that it returns unit. So we can do fun test equals run blocking test, which cannot be done with run blocking. So the real difference is that while with coroutines we just need to wrap it inside the launcher and everything is synchronous, with RxJava we either have to say that I want that to be synchronous, or we have to use the test operator and then do something with the assert value. It's not necessarily a bad thing, it's just slightly more complicated in my opinion. Again, this is a very subjective talk, so if you love RxJava and are fine with it, then it's fine. If you don't like RxJava and you're fine with coroutines, that's fine as well. I prefer coroutines. I think they are much easier. They are tricky for some things, but for the vast majority of times, I think they made my life much easier. So, before continuing, I wanted to actually talk about something that is not really related to this, but it will make the rest of the talk easier to talk. So, this is something that is called the LCE paradigm. So, every time you start a long operation, you wrap your data inside an event, and then you start. You'll emit the loading event, then the complete or success, based on how you name it, or the error. And when you restart that routine, it starts again with loading, then complete or error. Okay? Why is that? Because so you don't have to manage the different states from too many parts. You just say, okay, I started. This is my loading event. Whoever is listening receives this event and can react properly. So you don't have to invoke different callbacks. You just send an event, and based on that, the listener can actually react to that. So this is the implementation of something that I translated back to from Coroutines to RxJava, just as an example. So, of course, with the proper RxJava implementation, we would have used other tricks, but I wanted to mimic the exact behavior that we have. So, what we do here is creating our LCE object, well, more like a behavior subject there. Then from our store library, that is a repository pattern based on reactive Java as of now, we try to get whatever we want. That gets the whole data set. But since we want to invoke the loading first, we have to start with that. But when we get an error, because of course our store implementation actually throws errors, we want to wrap that into an LCE error so we don't have any crashes, and we go down the line. The map function is because if we have an empty data, which is not an error, we want it again to be an error. It's a different kind of error than the one that we throw on the error return, but it's still an error. Imagine the New York Times that has like an empty data set of news. Well, that's kind of an error. So I actually want to manage that. Even if for our repository it's not an error because it says, hey, I loaded everything you had. So, I mean, for these different in philosophies, we need to do that. So, whenever data is not empty, we continue and we emit the LCE complete or LCE success. It's the same. Then, of course, we need to tell RxJava where we want the result to be delivered and where we want our operations to be run. This is not really necessary because store already knows where to run and return stuff, but for the sake of clarity, I added that. I could have added also the description of map empty data, but it's simply if is empty, return the error, else return the success. Of course, we want to subscribe, and when the view model, because we are using a view model here, is cleared, we want to clear the subscription, so we avoid any leaks. But there are a couple of things here that are really complicated for new developers when they come into the team. So the first one is this one here. Because you have to know exactly what the behavior subject does, otherwise, well, you're stuck. So if you don't know what the behavior subject does, or you're like me, that you forget every time the difference between publish and behavior, then well, you always have to go and look up. This doesn't take much time, but it's time that breaks your concentration. And most developers actually take a while to get back into the correct mindset to continue doing what they were doing. So this is actually a huge deal. And also, it takes a while to actually parse this whole routine and understand everything that's going on. So the learning curve here is not actually the simplest ever. When I started using RxJava way before coroutines were a thing, well, it took me a while just to wrap my head around why my observable wasn't starting. Yeah, of course, I wasn't subscribing, that was my fault, but it takes a while. RxJava is great when you need streams and you need to parse them and combine them in ways that would be too complicated for anything else. But this is not really a complicated flow. It's literally, I'm loading. If there is an error, throw an error. If there isn't an error, well, I'm happy. So this shouldn't be this hard to do simple things. So of course, RxJava was not really thought for this specific use case. And it's actually very good when you need something, well, more functional. But, well, in my personal experience, I've never really had to deal with such algorithmic problems. So let's see how it looks like in Kotlin and Coroutines, shall we? Okay. So, well, this is actually quite easier in my opinion. So here we use live data. But I have to say that I wasn't a huge fan of live data at first. I mean, we used RxJava. We didn't have coroutines, so I was like, well, why do I need live data for? I have to say that I really reevaluate them from when I started using coroutines. So what we do here is actually creating a live data there in the very beginning, which is exactly, well, I forgot an LCE there, but that's fine, in the declaration, but well, I'll fix that. So when we load our function, the first thing we do is emit the LCE loading event, exactly like we were doing with RxJava. Here we don't really care in what thread we are executing, because the post value automatically will actually post it to the main thread. So it's fine. Then, since we are in the view model, and we have the view model extensions there, we can simply use the view model scope and launch our coroutines. Here there is a nice thing. So, as I mentioned earlier, our store library is actually based on RxJava 2. We're working on a porting to coroutines, but as of today is RxJava 2. So we used a nice library from JetBrains, which provides a bridge from RxJava to coroutines and the other way around. So by simply invoking the await method, that gets transformed into a coroutines. So which is nice. So there we get our data. If it's empty, we'll just send the error back. Otherwise, we send the success. Of course, everything has to be inside the try-catch, because our call can still fail. So if store.get.await fails and throws an exception, this is where we should go. Of course, in a functional world, try-catch is not the best, but I'm not really doing any functional programming there, so I'm actually fine with that. So what are the difference between what we saw with RxJava and what we see with coroutines? Well, the first thing here is the mutable live data. So here you don't need any knowledge, because if you want to mimic the behavior of the behavior subject, you can simply put an if at the beginning of the load current status and say, if the data contained here is not null, then you can remit right away, or you can force the loading again. So it's actually pretty easy. You don't really need to go and look for any documentation. Everyone that joins the team knows how an if works, and the only problem is the post value. But there again, somewhere there must be some knowledge, I guess. So here the routines that we have, it's actually pretty straightforward. There is nothing that takes us time to parse. It's literally, when I start, I do this, then I get the data. If the data is empty, I send the error, because again, we don't want an empty from page. This is actually a huge problem, so we want to recover from that. But we have to know that this is the error that we get is because it's empty. If we are here and the data is okay, then we can show it. But if anything there fails, we want to recover from that failure. This is why we have two different errors. We may have as many errors as we need, and with the LC approach, we can always keep track of what error we get. Of course, this can be done in many ways. This was just the most comfy for us, because we can just listen to the changes in output. We don't have any reference to the view, because with view model and live data, that works as a charm. And we don't even need to actually cancel any coroutines, because since we are working inside the view model scope, everything will be cleared when the view model will be cleared. Okay, so we talk about the first two things. So retrofit and moving things off the main thread. Then there are other things. There are the basic operators. So these are the operators from RxJava that I use the most. So basically mapping something to something else, or when map doesn't do what I want, I try with flat map. I know very few people that know exactly when to use flat map and when to use map. I'm not one of them. So I usually go with one, and if it doesn't work, then it must be the other. So, I mean, that's fine, right? Then there is the filter method, because sometimes I need to filter stuff. And like lately, I've been using quite a lot first and last. But these are basically the 5 operators that I use the most. Of course, there are many others. I used in the past quite a lot combine latest. If you ask me how to use it today, most probably I will panic and run away. But I know of its existence. There are many others, like switch map or anything like that. But I think they are much more advanced than my usual use with RxJava. And actually, I have to say that was quite a pain to use map every time I wanted a for each. Or actually need to use a filter when I wanted to just say, I don't want the null ones. So, luckily for us, with Kotlin, well, we have those and more that are actually something that are basic operators for me. Like, for instance, the for each. I mean, I don't always need to return something, so the for each is okay. And most of the times when I work with lists, I don't want nullable lists. I don't like nullability. I don't want to check every time if something is null. I prefer to work with empty lists, because for the way I work, dealing with empty is easier than dealing with null. First thing, it doesn't crash, which is already a good thing. Also, I always prefer to recover from the error whenever it's possible than actually crash. So I don't really like to put the 2 exclamation mark in the end. I really prefer to just append the or empty thing. And also, as I mentioned earlier, I can always use the filter and then append the map and say, okay, filter everything that is not null and then map this. But I'm lazy, I don't want to do that every time. So luckily, there is the map not null right there. And there are many others that I don't know yet. Like, for instance, the other day, I discovered that a friend of mine wrote a flat map with previous, so that you can actually flat map with the previous object in the list. I was like, oh, wait, you can do that? It was simply like a map and another map put in some magic. But I mean, doing that with RxJava would have required like at least 3 days and a lot of help from other people, while he could write that in 2 lines with Kotlin. So, okay, we're talking about Kotlin and Java, but I mean, okay. So why did I need to use that? Well, because for a specific element, I need just the first element in a specific position of the list to change a small flag. So I was like, how do I do that? Well, luckily with Kotlin it was easy. Well, not easy, but okay. So we talked about why I decided to switch from RxJava to Coroutines, let's see something deeper. Like, for instance, how we can transform something that was taught for RxJava to work with the coroutines. So, this example here, which is not really meant to be read, is something that I took from the Apollo framework. So, Apollo is a framework that we use when we need to deal with GraphQL endpoints. So, anyone here used GraphQL? Okay, I feel for you. I know it's painful. So, basically, GraphQL is another approach to network requests where you give more power to the client. So the client doesn't have a set of requests that he can make, but can create its own request and query the server for that. And the server will respond to that request. So you send over a query, and you get the result that you expect. The nice thing about that is that you have code generation, so your models are automatically generated for you. They're still in Java, so yeah. Or at least I don't have to write them, so it's fine. So this is the whole implementation that I need from the GraphQL callback to become an observable. Actually, if it was for the use I do, a single would have been more than fine, because we have a mechanism in place, so we can't really query database more than a certain number of times, which is more than fine, because otherwise it would be overwhelmed, because it's like normal. But what we could actually do with coroutines, it's something that is, well, slightly shorter. So I use the same font so we can appreciate the difference in the number of code. So, of course, the number of lines doesn't really mean anything. We already know that Kotlin is much, much, much shorter than Java in most of the things. At least for us Android developers that don't really have Java 10 or anything like that, and we will not have in the nearest future. So let's see how actually the Kotlin implementation works. So I'll move it a little bit because I have to read that. I don't remember everything by heart. So we create here a suspend cancelable coroutine because we might want to cancel that. I'm pretty sure that our repository at some point canceled the request for some reasons. I never did that manually, but that's fine. So inside, we just say we use the enqueue method on Apollo and just wrap our continuation inside the callback. So when we get an error, we say to the continuation, resume with this exception that we got from the callback, while when we get the response, we resume the execution with the response that we get. So it's really easy. Everything is generic there, so we don't need to do anything. I mean, the coroutine part is the second line, whatever is inside on failure and whatever is inside on resume. And when we cancel the coroutine, we just invoke cancel on the call as well. So it's really 4 lines of code to transform the callback from a callback to a coroutine. So, well, it was really easy. But of course, coroutines are not always easy. Yeah, they're incredibly easy to get started, but well, sometimes there are errors that are really tricky. Like when I started using coroutines, I usually found out myself writing something like that. So I created a job, then I created a scope with a dispatcher that I want. Then in my function, I would use the scope to launch or use async on anything. And of course, I would invoke cancel in the end. Everything looks fine and everything works the first time you invoke the function. If you invoke the doThings function the second time, well, it doesn't do anything. So imagine when you have that doThings that actually is something related with LCE. So what you do is actually always see the loading. I was like, what? Why it never runs? I mean, this function is invoked, but then I don't see any result. How is that possible? yeah, it looks like the cancel on the job actually alter the state of the job, so the coroutines cannot run anymore. One solution would be to actually create the job every time I want to launch the coroutine. Or I could have read the documentation a bit more and use something else. So instead of using the job.cancel, I could use the cancel children, or going from the scope, getting the coroutine context, and invoke cancel children on that. They actually do exactly the same thing. It depends on how you code. So if you keep a reference to the job, more than fine. If you don't, well, you can use the scope. If you are inside the view model, you have the view model scope. And the latter, view model scope.coroutines context.cancel children, is exactly what's been invoked. So those two actually do the exact same thing. How am I sure about that? Well, if you check the source code, it looks like they really are doing the same thing. So whatever you feel comfortable with using, just use it. Again, if you're fine with RxJava or have a huge code base, you don't have to do the migration all in one day. Exactly as you don't have to migrate everything to Kotlin in one day. When I started at the Nytimes, we had more or less the 3% of the code base written in Kotlin. After 2 years, we are almost at 50%. And our code base is quite huge. I mean, it literally takes 4 gigabytes of space on my disk. So it's actually pretty huge. So for now, we are working with coroutines only in 2 teams. But I'm pretty sure that I will win this battle and everyone will be using coroutines. But I mean, that's okay. So I think we actually have time for a few questions. I guess we have at least 10 minutes left. So these are all the URLs where you can find us. Or if you want to ask me questions that are not related to this talk, just come find me. I'll be around. And yeah, I guess now we can take questions, if we have any. Yep, we have a question here.
Thanks. Hi. In your last example, with the coroutine job, can you put that slide up again?
Sorry?
The last example you showed us.
This
yes.
one?
Yeah.
Okay.
What happens if you call do things while it's already running?
Well, it will cancel the coroutines, well, the children. I never actually see that happening because I never did that, but from the code that we can see, it actually will get all the children of the job and then call cancel on each of them.
No, I meant if you call the first method twice while it's already running and you call it again, will it start the job a second time?
Well, it will cancel on the children. Not sure if it will throw an exception. Definitely the job will not be affected, but I'm not 100% sure that actually it will throw an exception.
Okay.
I'll investigate that. Never tried. Thanks for the question. Any other question? Okay, thank you very much.